Before we start anything, let's think about how we can solve this question. In this question, you can see there are three types of angles in the tan terms. 2x minus alpha minus beta, x minus alpha and x minus beta. X minus alpha plus x minus beta value equals 2x minus alpha minus beta. We know the expansion of tan A plus B value. We can write as tan A plus B, tan A plus tan B over 1 minus tan A tan B. We can substitute A value as x minus alpha and B value as x minus beta. Then we can cross multiply the denominator and derive an equation for tan 2x minus alpha minus beta times tan x minus alpha times tan x minus beta value as a sum of difference of tan values. After that, we can simplify the integral using this value. Clear? Let's jump into the question. A plus B value we can write as tan A plus tan B over 1 minus tan A times tan B. Let A value as x minus alpha and B value as x minus beta. Then we can substitute instead of simple A and B value x minus alpha and x minus beta respectively. Then we can write tan x minus alpha plus x minus beta equals tan x minus alpha plus tan x minus beta over 1 minus tan x minus alpha times tan x minus beta. Now we can cross multiply the denominator value and get the result tan 2x minus alpha minus beta within bracket 1 minus tan x minus alpha times tan x minus beta equals tan x minus alpha plus tan x minus beta. After that, we can remove the brackets. Finally, we can subject tan 2x minus alpha minus beta times tan x minus alpha times tan x minus beta value as tan 2x minus alpha minus beta minus tan x minus alpha minus tan x minus beta. Let's substitute this value for our integral. After that, we can consider integral sign separately. Integral tan theta. Tan theta equals sin theta over cos theta. Differentiation of the cos theta value equals minus sin theta. To get minus sign, we can put minus sign in front of the sin theta term. To cancel out this minus sign, we can put another minus 1 value outside of the integral. We have differentiation value of the denominator in the numerator. We can consider integral answer as ln modulus denominator. In this case, we can write ln modulus cos theta. So we can get integral tan theta value as minus ln modulus cos theta. Using this equation, we can write integral tan 2x minus alpha minus beta value as minus ln cos 2x minus alpha minus beta divided by 2. Here, coefficient of x value equals 2. That's why we divide this answer from 2. Integral tan x minus alpha equals minus ln modulus cos x minus alpha. Integral tan x minus beta value we can write as minus ln modulus cos x minus beta. Then finally, we can get minus ln modulus cos 2x minus alpha minus beta over 2 plus ln modulus cos x minus alpha plus ln modulus cos x minus beta.